Hello everyone, welcome to our AriserTalent. I'm your maths teacher Arpita Sharma. Students, in today's lecture, we are going to do the revision of our entire chapter, that is linear equation in two variables. Right? So, just I'm writing this name of the chapter here, linear equation in two variables. Right. So this is our chapter, linear equations in two variables. Okay. So till now we have discovered all categories and kinds of question in our lecture, right or wrong, right? So far we have discussed very much concepts related to this particular chapter, and now it's really helpful. It will be helpful for us guys just to rewind all that, just to summarize all that, so that we can assure that we have understood all our is something there which is remaining. Okay, so talking about this, I've talked to you about linear equation in two variable. First, I've taught you that we are having polynomial, and if in polynomial or in an expression, if you use the equal sign, okay, equal sign and equate with it 0 or any other number or any other thing, then that thing will become as equation. Now, linear is what? You have studied linear polynomial. Okay, so linear polynomial is having the highest degree as 1. The highest degree as 1. Okay, so in this condition also we are having the highest degree of equation in this. Not about polynomial but about equation. So, equations highest degree is what? 1. That is linear. Okay. So, a statement of equality using equal sign of two algebraic expressions which involve one or more unknown quantities known as equation. If there are two unknown quantities, then equation is called linear equation in two variables. Variables are two. In our case, we studied like x and y. Mostly we understood that by x and y, right? Now, a linear equation which involves linear polynomial, I have told you linear polynomial is having only one part. Okay. Linear equation two variable. If you are having linear equation, that is the highest power is 1, but having two variables. Here we are having two variables, so that will be known as the linear equation. Now the solution of the equation is what? If you find out the values at which the right hand side is equals to left hand side of the equation, that particular value of, let's suppose, variable x and y. Okay, so that value of x and y will be known as the solution, because putting these values will be giving the LHS equals to the right RHS, right? Okay, now the third thing here, same quantity can be added. We have understood that if we are having like a1x plus b1y plus c1 equals to, let's suppose, a2x plus c3 something. Okay, so if I add something here, let's suppose not a1, let's suppose any constant c, and I have add c here also. So if I am adding on the both side, this equation will not change. That means that side which is right hand side will be equals to left hand side, this thing. If I subtract this, not like this, but yes, subtract. Okay, so minus c and minus c, then also the equation be same. If now what I am doing, I am multiplying this with c. Again, I am here also multiplying it with C, any constant C, right? Any constant, any variable also. If I am multiplying both, then this this equation will not be changed. That means this equal sign represent here that LHS, RHS are equal, that will remain same. Okay. If now what will I do? If I divide them both, then that will remain same. This we have studied here, that same quantities can be added, same quantity. Now the thing is same quantity can be added and subtracted to or from both sides of an equation without changing the equality. Now both the sides of an equation can be multiplied or divided by the same non-zero number, okay, without changing the equality. Then notice, to find value of variables in any equation, we require number of equation equals to number of, say, variables. So here number of equations should be number of variables, right? Okay, this is given here. Next, general form of pair of linear equation. We have some standards, right? So we are also having standard of our linear format. Linear equation, two variables is having a specific format, which is what? A1x plus b1y plus c1 equals to 0, and the second pair will be a2x plus b2y plus c2 equals to 0. Now why there is a pair? Because we are talking about two variables, and if we are talking about two variables, then we have to be ready with the two equations also. Why two equations? Because we are having two variables, and we studied that to find the value of variables, we have to have the number of equations equal to number of variables in equations. So for two variables, we'll be having two equations, right? Where these are what? Constant. A1, B2, A2, B1, C1, C2 are all what? Constants. Now we have studied about graph of linear equation ax plus by plus c equals to 0 in two variables where a is not equals to 0, b is not equals to 0. If I am not talking about the pair, I am only talking about the linear equation ax plus by plus c equals to 0, which is standard equation, standard format. So step first for that, obtain the linear equation in this format. If it's given in another any format, so you have to convert it first in the basic format, and by this basic format of our equation, will be moved to step 2. What is step 2 here? Express this term of y. Now what will you do? You will put some values of x and will find out the values of y at that particular time. If x equals to 0, you will be finding the value of y equals to minus of c by b. If x equals to 1, then you will be finding the value of y is equals to minus of a plus c by b. Okay, this is the way you will be finding the value of y's when you put some value of x. So now you will be having some values of x and some values of y. Okay. Now in the step 3rd, what will you do? You will be having any two values of x and the corresponding values of y. What do you mean by the corresponding values of y? That means for specific value, let's suppose we have this value 0 here. So x equals to 0 and y equals to minus c by b. So first value is what? First value is 0, x 0 and y is minus c by b. Now let's suppose I am taking this 2, x equals to 2 in the second one. So that will be x equals to 2 and y equals to 2a plus c by b. So 2a plus c by b of minus. these will be the two values. This is the first point, this is the second point of the graph. Now we know how to plot these points on graph. Okay, so what we call it? Solution, say alpha 1 and beta 1. Alpha 1 and beta 1. So this is alpha 1, this is beta 1, and this is alpha 2, and this is beta 2. Right. Alphas are the values of x and betas are the values of y. Right. Now, step 5th, plot points alpha 1 and beta 2 and alpha 2 on the graph paper. Now, we have discussed about this graph. Okay, we have discussed about the graph. Right. Join the points. How will we write that? We'll be saying that if this is some axis y dash, and this is what? X and x dash. Right. In the graph paper, you'll be able to see they are the boxes like this. Right. They are the boxes like that. Here also. Right. So these are the vertically parallel and horizontally parallel lines. So should I differentiate this particular axes with the different colors? Okay. So now what? It's the 0, 0 point. This is x axis, x dash axis. So this is 0, this is 1, this is 2, this is 3, this is 4, and so on. Like this, when we come this side, this is the right side and this is the left side. So the left side, the values will be in minus 1 in the number line. Okay. So what I am doing, basically I am plotting the number line. This is the number line, -2, -3, -4 and -5 and so on. So this is the number line, you know number line basically. Okay, you have studied in 9th class also, and we have discussed in our 10th class also in the first chapter. Okay, you can visit that. Now, I have on the point 0, I have created a perpendicular line, and this margin, this portion is exactly same this portion. So, I am counting like horizontally I have made this, now vertically I have also made this like 1, 2, 3, these points, 4, right. Now, here again. So, this is positive, upside is positive and downside is negative, -1, -2, -3, -4, -5 and so on. Okay, now this is 0. Now, let's just suppose that we are having from any equation we are having alpha 1 equals to 3 and beta 1 equals to 7 and alpha 2 equals to -3 and beta 2 equals to let's suppose 2. Okay, so what does that mean? So the points are, let's suppose P is alpha 1, beta 1, that is 3 and 7, and the Q points is beta 2, alpha 2 and beta 2, that is -3 and 2. What I have take? I take x equals to 3 and find out the value of y equals to 7, something like that. I have put the same value of x in negative form, that is -3, and then I got the value of y equals to 2. Okay. Now what will I do? How will I plot the P here? 3 and 7. Now 3 alpha 1 value of x and beta value of y's. So value of x is 3. So now value of x this line, 3 here. Okay. Now the value of y is 7, right? So we are not here with the 7. So I'll just write this as 4. Should I? Because that will be in the area of our graph. Okay. We don't need to extend our graph. So that is 4. So value of y here is 4. Now what you have to do? you have to just draw here a line and here a line. The intersection of these two lines will give you a point here. And this point is what? This point is 3, 4. That is your point P. You can write it like P equals to 3, 4. Or here with this, I can make it more clear to you. P equals to 3, 4. Right. Similarly, I am having Q equals to -3. Now, Q equals to -3. Can I take this minus also? So that you will be having the clarity of minus also. Okay. Now, Q equals to -3. Now, -3 is the value of x. So, 1, 2 and 3. This is 3 of minus the value of x. Here is the point. Now, the second is -2. Now, -2 in the y-axis. In the y-axis, I am having 1 and 2. Here, -2. Okay. So, I can draw these two lines and the intersection is here. That will be Q and the coordinates will be, this is, we will always write the x value, that means alpha values first. So, alpha values is -3 and the beta value is -2. Okay. So, that will be, now how will we create line here? We'll just simply, with the help of scale, we'll simply need this to this and that will be this line. That will be this line. Okay. So, basically, this line will be what? This line will be the, let's suppose we have equation that L1. Okay. So, this is the equations line. This is the line of equation, let's suppose ax plus by plus c that we have given, that we have provided. We have just imagined this condition. Okay. So, this is the idea about the graph. Okay. Noted? Okay. Now, we have drawn some graph, then graphical representation of a pair of linear equation. Now, student, we have understood the graph concept and then we have find out that there's always not possible to draw all things and graphs. So, we discovered that there are some specific method that we can apply and we can just solve the values. Okay, and will not use graph but do it directly. How does that benefit us? Because graph is not always very concise, very precise. There is always a possibility of error. But when we do it mathematically, then numerically, then the possibility will decrease for the error. Okay. Let the system of pair. These were two systems. We know that given two lines in a plane. Okay. Because linear, only one of the following three possibilities can happen. What and what possibilities can happen here? These two lines, I have told you what possibilities can be done if a graph is here. X dash, y and y dash. What and what are the possibility? Possibility 1. This is the first line. Let's suppose L1 and let's suppose this is the second line L2. So, first is that they are intersecting to each other. Okay, in that condition what? There is an intersection point. Now, second condition, there may be a line, right, and there may be another line. These two lines are what? Let's suppose P1 and P2. These two lines are parallel lines. So, this is the second condition. First condition is here. This is the second condition. This is the first condition. Now, what can be the third? The third one can be like I am having this line, first line, which is R1, or I can write it O1. Now, I am having again I am having a line which is overlapping this line, and I'll tell this O2, and now this is the third pair, third condition. The first condition First condition, they are intersecting. Second condition, they are parallel, and third condition, they are overlapping. That can be that will be the three cases. So first is this intersection here, right? The second, they were parallel. Okay, you'll extend them infinitely, but you will not find any intersection, so that will be parallel. The third one, they will be overlapping. So these are three conditions. Okay, understood? Then types of solution: unique solution, infinite many solution, and no solution. Now understand this. If this condition exists, this is having unique solution. This will have unique solution. What? Intersection will have unique solution. If I am having this second thing, this thing, these are parallel. So these are if this first is not having this not going to happen, that these two conditions will arrive. Now infinite many solution. Infinite many solution will be where? When these two will overlap. Now these two are overlapping, so this will have infinite many solution. Many solution. Okay, that is second. Now no solution. For parallel lines, there are no solution at all. So we divided them in consistent and inconsistent. Remembered? Okay. So if a system of simultaneous linear equation has at least one solution, then the system is said to be consistent. Okay, at least one condition. So can I say at least? That means this portion and this portion. These two portions will go in, consistent solution, right? And that will be inconsistent solution. Right, consistent solution and inconsistent solution. Here we are having two cases with consistent. What? Consistent equation with unique solution, right? When the equations are intersect. Okay, then this is the graph we have studied. The consistent equation with infinite many solution, that will be the graphs of the two equations will be coincident. Here they will be coincident, right? Overlapping. So this is also consistent. Then inconsistent solution was what? Consistent solution, we are having no solution in the case of parallel lines. So parallel lines are here, so that will be inconsistent system, okay, or equation, right? So this is about this. Now if we talk about graph of two equation, type of equation, intersecting line, this first type, okay, I can write here with the color of chalk like in intersecting lines. Okay, so I am writing this particular chalk, so that is this is inconsistence, right? And if I talk about this is coincident, that is my yellow color is where? Here. Okay, so that is right. And if I talk about the parallel lines, so parallel lines are in this color, so this is okay. So if I talk the tabular form, intersecting lines are having consistent with unique solution, coincident will having consistent with infinite solution, and parallel lines will having inconsistent with no solution. Okay, then we just talked about some questions here. Then this. Okay, now I am rubbing this graph. Okay, so here I am having the parallel lines of here I am having lines, pair of lines, that is a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0. Now in this condition we have discovered that these ratios, if this is a1, a2, b1, b2 and c1, c2, then these ratio will will show something like sometimes we are having A1 is not equals to A1 by A2 is not equals to B1 by B2. Sometimes we will be having A1 by A2 equals to B1 by B2. In that case, we are having two cases. A1 by A2 should be equals to B1 by B2 and it's also equals to C1 by C2. In second case, these two are equal but the C1 and C2 are not equal. Basis of this, we have also shown that this is what, this is overlapping, this is what, this is intersecting, and this is what, this is having what, these are what, parallel lines, right? Now, this is not parallel line, this is parallel line, this is, yes, this is parallel line, this is overlapping and this is intersecting. So, this is intersecting, right? These are the parallel lines and this is, no, it's not parallel, this is our overlapping and this is a parallel line, okay. So, intersecting line, exactly one solution, constant line, infinite manifestation, we have studied that, right. So, for intersecting line, you are having this here, and for coincident line, you are having this here, and for parallel lines, you are having this here, okay. So, this is the way you will be studied in format. Now, on comparing the ratios, we have done this kind of question. In that we will be just having the proportions, and by the only just calculating the proportion will be known to this that whether they are parallel or not, constant or not. Okay. Now, algebraic solution of system of linear equation. So, we have gone with the algebraic solution. Why algebraic solution? Why algebraic solution? Because it's always not precise to solve the questions by graph. There is some chances of error, some mistakes. So, we will be go with the algebraic solution of A. Now, okay, so we are having these three elimination method, elimination by equating the coefficient and the cross multiplication method, right. Now, substitution method. In substitution method, what we did, we find out these two equations, right. In these two equations, what we did, we find out the value of, let's suppose x or let's suppose y. So, okay, we find out the value of y and put this in the equation number 2. From the from this we put have the value of y in terms of x and put the value of y in terms of x here and find the value of x. After find the value of x, we find out the value of y. Okay. So, this was about this. We have done some questions on it, method of equating the coefficient. In that, what we did, we multiply this by A2 and this by A1. Now, what it became, this will be the same. Now, if the signs are opposite, just add them. If the signs are same, then just subtract them and you will be finding only this will cut and you will be remaining with only y. From here, we will be finding the value of y and then substituting the equation so that you can have the value of x as well. Okay. Now, about these two variables, we have done some questions. So, we have discussed some types here. Okay. Right. Reducible system to a linear simultaneous linear equation. Right. Like this, we have consider this complete as P and complete as Q or X. Right. Not X and Y, but P and Q. Okay. So, we considered that also. Again, type 3 equation of the form, this equation format. Here, what we did, we are having this and we are having this. So, what we did, just we write the equation in this format. Now, not here, plus C is not here, plus C is here. So, we change the format here and then we just what? We add them and we subtract them. We add the both equation and subtract both equation and we'll find out this. Okay. And after that, we'll be having this x plus y equals to something constant and x minus y equals to something constant, and we got the values from there and we have the solutions. We have the problems, we have discussed the problems of them. Then equation of form, this format. In that, what we did, we pick any first equation and convert it in the form of two variables, like that you can find the value of z from there and then put that value here. Then you will be finding out some value and then put them here. So basically what are you doing? You are doing eliminating z from this equation, okay, from this equation, finding out the values in two format. Now we are having this equation in the form of y and x, and also this form equation in the form of x and y. Now you can solve this clearly because they are two equations with the two variables, right? So these are the steps. Okay, now the cross multiplication method. In the cross multiplication method, we saw all complete procedure, but we find out this x minus y and the constant, and what we did, we have this a1x plus b2y plus, sorry, b1y plus z equals to 0 and a2x plus b2y plus, that's not z, that is c1 and that is c2 equals to 0. In that we find out that we'll hide that and we'll cross multiply these coefficient, and we'll hide that and we'll cross multiply this coefficient and we'll put minus sign in between. Likewise, we'll hide that and cross multiply this. So we'll get these coefficient in that, x, y and the coefficient. Okay, then we'll solve the questions. So we solve the questions here, right? Okay. Now on these particular principles and the characteristics of the linear equation, two variables, we find out the values and we find out the homogeneous equation. Okay, and we then moved on the word problems of simultaneous linear equation, and we know about these all number system and the distance type questions, right, and the and the stream questions, right, and the triangles, the geometric figures question. Okay, so we covered all these categories of question and the coefficient and the relations. So we covered all in that one, right? So this is about today's lecture. I'm concluding this lecture here. We have just completed this complete session here. Okay, so in next lecture we'll be meeting with new chapter. Okay, bye bye, take care.